Section 8.6 covers the solving of exponential equations and logarithmic equations, and the principle is quite simple. For any a greater than 0 and a not equal to 1, a to the x equals a to the y implies that x equals y. In other words, when the powers are equal, the exponents are equal. So let's apply this to some exercises here. 3 to the 2x equals 9. So we can rewrite the 9 as 3 to the second power. So now the exponents are the same. That means 2x equals 2, which means x equals 1. So that's how we solve that kind of exponential equation. Similarly, when we have number 2, 4 to the 2x minus 3 equals 64. We're going to write 64 as a power of 4. So that'll give us 4 to the 2x minus 3 equals 4 to the third power. Again, the bases are the same, so the exponents are the same. So it means 2x minus 3 equals 3, or 2x equals 6. So 2x equals 6, or x equals 3. So here's a principle of logarithmic equality for any logarithm base a and for x and y greater than 0. The log base a of x equals the log base a of y implies x equals y. In other words, if the logarithms base a of two expressions are the same, then the expressions are the same. Expression meaning x and y. So let's apply this to a guided solution example here, where we have 7 to the x equals 20. So we take the log on both sides, and so that means log, and of course we have the common log base 10, write that, but it's a common log, equals log 7 to the x equals log of 20, and then based on the power rule to the power rule of the log, this means x times the log of 7. We solve for x by dividing both sides by the log of 7. So in other words, x equals the log of 20 divided by the log of 7. And that means it's approximately equal to 1.5395. In other words, we look up the log of 20, we look up the log of 7, we take the quotient of the two numbers, and that's equal to 1.5395. So you can do that on your calculator. Now, just note this. This is important. The log of 20 divided by the log of 7 is not equal to the log of 20 divided by 7. Okay, it's not the same. You have to evaluate the log of 20, you have to evaluate the log of 7. Again, look it up on your calculator, and then divide these two numbers to come up with the answer. And it's approximately this number because this is rounded. To find the solution to this exercise, e to the 0.3t equals 80, we take the natural log on both sides. So it's ln of e to the 0.3t equals the ln of 80. Of course, ln means base e. And so that means 0.3t times ln of e equals ln base e of 80, but the natural log of base e is equal to 1, so we have 0.3 t equals the natural log of 80, and the natural log of 80 is approximately equal to 4.38. I'm going to round it to 2. So then when we divide by 0.3 on both sides to isolate t, then t is approximately equal to 14.6068. Again, that's a rounded value for t. So here, note that the natural log base e of e equals 1. Like the log of any base to its base is equal to 1. Solving logarithmic equations. Solve log base 5 of x equals 2. Remember the basic definition what this means. This means x equals 5 to the second power. So in other words, x equals 25. Solve log base 3 of 5x plus 7 equals 2. Again, looking at the basic definition, this means 5x plus 7 equals, the base is 3, so equals 3 to the second power, or 5x plus 7 equals 9. We subtract 7 on both sides, then 5x equals 2. Dividing both sides by 5 means that x equals 5 divided by 2. So here's how we solve a logarithmic equation. First, try to obtain a single logarithmic expression on one side and then write an equivalent exponential equation. So solve log of x plus the log of x plus 3 equals 1. So based on the rules of logarithms, this means log of x times x plus 3 equals 1. And remember, this is base 10, the natural log, the common logarithms. So from the basic definition of logarithms, that means x times x plus 3 equals 10 to the first power. 10 to the first power, or simply 10. So then on the left side, we use the distributive property. X squared plus 3x equals 10. Or x squared plus 3x minus 10 equals 0. And so this is a quadratic equation. We can factor that into x plus 5 times x minus 2 equals 0. We set each factor equal to 0. So x plus 5 equals 0 implies x equals negative 5. And when we set the factor x minus 2 equal to 0, we get the solution x equals 2. Now we have two solutions, and it's really important for these type of equations to find out which solution applies, one or both, or none. So when we replace x with minus 5 in the original equation, the log of minus 5 plus the log of minus 5 plus 3, is that equal to 1? Well, the log of a negative number does not exist, so that's a no. When we replace x with 2, then we have the log of 2 plus the log of 2 plus 3, is that equal to 1? Question mark. Well, this means the log of 2 times 5, is that equal to 1? Well, that's the log of 10. The log of 10 base 10 is equal to 1, so that is correct. So in other words, the solution is x equals 2. X minus 5 is not a solution in this case. Next, we have a guided solution in a similar way. Log base 3 of 2x minus 1 minus log base 3 of x minus 4 equals 2. So that means the log base 3 of 2x minus 1 divided by x minus 4 equals 2. Now we go to the basic definition. We erase everything where we write this as 2x minus 1 divided by x minus 4 equals 3, because it's base 3 to the second power, or 9. 2x minus 1 divided by x minus 4 is 9. Now we multiply both sides by x minus 4. So on the left side we have 2x minus 1 times equals 9 times x minus 4. So we have 9x minus 36. And we subtract 2x on both sides and add 36 to both sides. So that means 7x equals 35. Then we divide both sides by 7 to isolate x. And 35 divided by 7 equals 5. So let's check the answer. X equals 5 in the original equation. So that means the log base 3 of 2x, which is 2 times 5. 2 times 5 minus 1 minus the log base 3 of 5 minus 4, is that equal to 2? So then we have log base 3, 2 times 5 is 10 minus 1 is 9, minus log base 3 of 5 minus 4 is 1, is that equal to 2? Well, this means log base 3 of 9 divided by 1, is that equal to 2? Well, 9 divided by 1 is 9, log base 3 of 9, is that equal to 2? Well, this equation means 9 equals 3 to the second, and that is true. So therefore our solution x equals 5 is correct. This concludes section 8.6.